Welcome to another GibbsCam version 14 video. As promised, we're going to machine your very first mill part we did previously, where we went and drew everything using geometry and not solids. So here's our part that we drew on the previous video. You can see everything is at the top Z0, and the last thing we did last time was move our origin over to the top left corner right there, as you can see. Okay, so now we need to machine it. Now I want to pocket all this material out before we do some of the inside. We just turn off the show stock and origin there. So we need to make what they call an air wall, because we're going to use high-speed volume mill to cut that. So I'm going to bring up my geometry palette right here, and I'm going to click on, this should say here, shape and square or box. And we know our stock size looking before was 4 3/4 by 4 3/4 because we moved our origin to the top left corner. So I'm going to type in 4 3/4 and 4 3/4. Now make sure you pick where you have the origin. You don't want to pick here, because this is what you'll end up with, which you don't want. So make sure you tell it where the origin is in the top left corner. Click do it, and you have a box the same size as your stock. So we need to allow Gibbs to bring the end mill past this stock. If we leave it as a wall like it is now, then the end mill will stop at the edges here and the corners, so it'll never clean this out. So we have to tell Gibbs that we can go outside this stock here to clean all this up. So I'm going to just double click on the shape, and I'm going to go up to modify and click on toggle wall air. Now when you do that, you click in space, your geometry will be red. So that's telling Gibbs that it can go outside the wall what it needs to in order to clean this up. So now we need to pick our tools. I'm going to go through each one of these tools, so you can stop the video if you like and take pictures of it so you can create the tools. Here's my first tool, face mill. You can see everything I have filled out there. And I also call it face mill in the comments. And the reason I do that is you can hover your mouse over here and it'll bring up the comments for each of the tools. So that was my first one. Now the second one is 3/4 inch rough end mill. You can see the values there. Tool holder, call it. Next one, 1/2 inch rough end mill. Basically the same, call it. Next is a 3/8 end mill, because remember we have to go around the outside of this, and this is a 190 fillet, and that means we have to use a 3/8 or smaller end mill to finish. We could use anything we want to rough it, but to finish it, if we want to be to print, we have to be about a 3/8 end mill. Next tool is going to be a spot drill. And nowadays there's combination spot drills, chamfer tools, so that's what I call this, and that's what it's going to be. We're just having a 90-degree angle, which means it'll put a 45-degree chamfer around the part, and multiple flutes. And this one is going to be a 3/16 drill, or 187. Notice with the new version 14 you have a drop-down menu that you can use numbered drills or letter drills now, without having to look at the chart. We're not running in millimeters. That'd be much easier. Okay, and our last tool, 3/8 drill. Okay, so hopefully everyone has a screenshot of that. So as in the last, and we're going to leave 50 thou of stock, which would mean it's a -1.2 overall thickness, because our part's 1 inch thick, and I have a 200 thou clearance. Of course, this needs to be a Cat 40. Okay, so now we're ready to start machining it. So I'm going to bring up my cam palette. Just click on a blank screen there. So the first thing I'm going to do is face mill it off. So I'm going to bring up a face mill. So this is a roughing process here, right here, roughing. And when you do that, It's going to ask you if you pick roughing, what tool you would like to use. Or you can do it the old way and drag a tool down on top of there. So either way will work. So I'm going to do multiple process here. So the first process, I'm going to click on face milling. You can see you have offset, zigzag, offset, cleanup, and face mill. So we're going to choose face mill. I'm rapiding to 200 thou above our part. Remember, there's 50 thou of stock left on the face, and I'm going to machine it down to Z0. Now on here, I'm going to actually leave 10 thou stock on the Z, cut width about 1 inch, and you can either update your speeds and feeds with the material you're cutting, or let Gibbs figure that out by the material you chose here. You can always edit this database to what you like. And I can do it either by stock or by shape. If you click shape, then it wants you to click on a shape to cut. We're just going to do stock, and it'll clean up the rest of this face here. Now I always think about where it's going to throw the chips on the first cut. So if you have it going from, say, the left side forward, it's going to throw these chips right at you right through the door as you're the operator. So if you have the door open by chance, then that wouldn't be good. So we want to keep the chips thrown to the back. So you can choose the corner you want and the first move you'd like to make. Now the clearance is how far do you want the face mill or cutter to move off your part before it switches over to go the other direction. And I just chose 1 inch there. So everything looks good there. Now the second process, basically the same thing, but I'm not leaving any stock here. So about the same thing. If I click on redo or do it, in your case, if you're starting out with new, this is the toolpath you're going to get there. Now we could either render now or wait till we're done, but sometimes I like to render in between. So if you bring up your Operation Sim, don't click on Machine Sim unless you have a Machine Sim to go with it. Click on Op Sim. So if you click on Op Sim, rewind and play. Slow it down a little bit. You can see facing that off, then taking the finish pass. So now we're down to Z0. Okay, so the next operation, I'm just going to clear these out. The next operation is going to use high-speed volume mill as well, but this time we're going to take out all the material out here. Now if you don't like this annoying toolpath showing up here, it's because these are still yellow. So if you want, you can just click an empty space and just zoom up or zoom down. That'll go away. So the next process I'm going to do is going to be a volume mill process right here. So click on that and it'll ask you the tool that you would like to use. In this case, tool number 2, 3/4 inch end mill. So this is, I can use my Technology Expert, which works fantastic. You can tell it what you're cutting, the taper, the maximum RPM of your machine, the max feed rate, depending on your machine. I usually put out about 1,000 or maybe faster. And how are you holding the workpiece? Are very rigid, loose, or kind of in between? And how aggressive do you want to be with the cut? If you want to get real aggressive, you can put that over there, but this is pretty good. I usually start about here or less to start out with, make sure everything's okay. And how are you holding the end mill? Most of the time, if you're doing high-speed milling, large depth, you want to use either milling chuck, hydraulic milling chuck, or shrink fit. I find with end mill holders, or not end mill holders, but ER collets, it'll pull the tool out of the collet pretty easy when you get aggressive. So I would choose one of these last 3 here. So if you do hydraulic chuck, that's fine. And now you can say uncheck all, check all, or if I did check all, you can click on apply all or apply checked, and it'll fill in the blanks for you here for your speeds and feeds, which looks pretty good. Okay, we're rapiding to point 2. We've already faced the material off, so that would be Z0 now. Again, point 2, and we want to go minus 1.050. Our part's an inch thick. I'm just going to go down a little bit deeper than that. And usually with high-speed milling, most of the time you don't do it in steps if you can help it. I'm just going to put 1.5 inches, but it'll round it off to 1.05, which is basically the full depth. I'm going to leave XR stock. Volume mill is just roughing only. It is not made to finish. And minimum tool path, I put this here. Well, that's kind of a default, but the smaller you put this, the farther it'll get into corners. Okay. Repositioning parameters, that means after it cuts and goes to do the next move, it's going to move up to 110 thou, and then high feed rate, I'm just going to put 1000, because volume mill does not use any G0s, because G0s are unpredictable. It'll write it as a G1 move, so it knows exactly where it's going to go. And we're going to plunge type helix there, which looks good. So okay, for here, so here let me just choose an empty screen there so you can see what I'm clicking on. So click on your box. You can either single or double click, it doesn't matter. It's already chained up, so Gibbs knows. Hold down the control key and select one of the edges on your part, or you can double click that as well. Either way will work. So I'm going to click there, and I'm going to actually click on redo since I already have an operation there. And it takes a few seconds, and you'll see there's the toolpath, really nice and efficient, cuts that out really good. So let's go to the rendering on that. So we're going to face it off. Again, finish, and then the next step is to rough this part out. And I told it to side mill cut only and to conventional mill. Okay, so that roughed all this out and left stock on the island there. Okay, we'll clear this out. The next operation you want to do or process will be another volume mill process to click here to do both these cavities. So in this case, I would just double click here, choose volume mill, and this time we're going to use a tool number 3, which is the 1/2 inch end mill. Okay, it's going to fill in the blanks there. Let me bring this back up here since I already have it done. Again, point 2, our part is 3/4 thick, our cavity. Again, using volume mill, fill in the blanks there. Can leave some stock there on the XY and some Z stock as well. And again, we'll put this up to 1000. And again, we're going to do a helix, and this time you can select both pockets. And I'm going to click do it. In my case, redo, since I already have a operation over there, and there is our pocket. So if we were to render this now, we'll go up to that point, slow it down a bit, and it's automatically going to helix down into our cavity. Okay, now this one I wanted to go in a little bit closer to some of the corners there, so on the minimum toolpath radius I put 100 thou in there, and that'll get it a little bit farther into the corners there for me. Okay, the next operation is going to be to finish these pockets. So we're going to go under the floor and finish these pockets. Actually, I could do both at the same time, so I'm just going to delete that other one. So here we're going to go tool number 4, 3/8 end mill. I'm going to go right to 3/4 of an inch, and even though I chose a roughing process right here, just because it's a roughing process does not mean you can't use it to finish. So I want to actually finish the floor as well as the sides. So I'm going to go 3/4 deep. Cut width 0.2 is fine. When it gets to the edge of the walls, it's going to enter and exit at 100 thou radius. These don't need to be the same. They can be bigger or smaller. They don't have to be the same. I'm going to climb mill. Everything else looks good here. So again, I'm going to click on this cavity, hold control key down, select that cavity, and of course you'll click do it. In my case, I'll just click redo, and that finishes the inside cavities. So let's go to that point. We'll just speed it forward here. And there we finished. Okay. Now it went to the outside again because I told it just to use that tool and render everything there. So the next operation, operation number 7, is going to finish the outside. Now in this case, it's a 3/8 end mill going an inch deep. It's getting a little long. I'm afraid it might vibrate, so I'm going to do basically a helix down. If I go to side view, you can see that. So I'm going to bring up this operation, which is a contour with tool number 4, the 3/8. Again, choose your RPM and feed rate. We're going to go down to -1 inch because the outside is 1 inch deep. I'm going to go about 20 thou deeper than that. Again, I do an entry and exit there. And desired step, that means 200 thou. That means every time it goes clear around the part, it's going to go 200 thou deep because I have ramp down on there. So it's going to do a helical move around the part. I'm leaving no stock. And from here, you can choose whichever side you would like to start on. I'm going to start there, climb mill, so you want to choose the outside circle there. If you wanted to start off your part, you could easily drag this off here, and you can see it starting off the part there. If you wanted to finish on there, you could do that as well. You can see you can start and end at different points. If you wanted to do a redo that. If you want to do an overlap so you don't have it enter and exit at the same point, because you might have a little witness mark there, you could open that process and you could say overlap by 1/2 inch. Click redo. You can see now it's spaced out a little bit more. So a nice way to cut that. Now when it gets to the very bottom, it's going to stay on the floor one more time around so you don't have a ramp at the bottom. So if we render again, okay, we'll slow this down a bit for the finish. There, it's finishing that cavity, and then it's going in, and as you can see, it's ramping down the part. Okay, so that's finished there. The inside cavities, outside cavities, all looks pretty good. Now the rest of this would be to do the holes. So let's clear that, bring up another process. This time it's going to be holes. Okay, and with we need a spot drill and then we need a drill. So our process is going to be first tool number 5, which is our combo spot drill and chamfer tool. Again, point 2. If we look at our print that we did before, you will see it has a chamfer on there. Well, this is a 187 holes through here, but I want to give it the print, I believe, says 20 thou chamfers on everything, so that'd be 20 thou on each side. So if I type in this little symbol here, you'll see it says diameter. First you have to tell it where the surface is you're cutting, which is 0. And here I'm just going to type in and let it do the math. So 0.187 is our drill size plus 40 thou makes it 227. So then Gibbs will calculate where the sharp corner is of the drill and the depth. Now this will change depending on the angle of your drill. In this case, I have a 118 drill angle. You could use a 135 or whatever you have on hand, and this will update this as well. So click on there, and I'm going to select each one of these. Now Gibbs doesn't care whether you select the point or a hole. Either one will work fine. Just don't select both of them, otherwise it'll spot drill it twice. And you click on do it, and you'll see it spot drills a hole. Now this is a 3/8 one, so it has to be separate. We want to do a little bit bigger chamfer there. So the next process is going to be the same tool, a chamfer tool, but this time this is a 3/8, so I'm going to type in 0.375 plus 0.040, 415. Okay, so this one I'm just going to click on here and click on do it, and you'll see that it spot drills those. So let's just quickly render this. Okay, finish. So there's the spot. So it spotted everything exactly how we need it. Now the next process operation we're going to do, clear this out, is going to be the 187 holes. So I'm going to choose the 187. Material 0. I want to make sure the edge of the drill gets clear through our part. Remember, our part's an inch thick, so I'm going to say -1, and I'll give it about 30 thou, so it's going to go 1.030. The tip of the drill is going to be -1.086. Of course, you'll do your RPM and feed, and whether you want to feed in, wrap it out. Normally, if you're doing high-speed drilling with high-pressure coolant, 1000 psi, you no longer need to peck anymore. It's feed in, wrap it out, the chips will blow out. If you don't have through spindle coolant, you may want to do a peck full out or a peck chip break. It's up to you. So we'll do that one. Just redo that one. Now next is tool number 7, which is the 3/8 end mill. Same scenario here. Just going to do that hole. So make sure you only select what you're going to cut. Don't leave these all selected, or you're going to end up drilling all of them. Okay. Then we want to do some chamfers here. So tool number 5, this was the combo chamfer and drill. So I'm going to go down now. If you know your trig here, 90 degrees and 1/2 inch, that means you only have a 1/4 inch to play with before you're up on the straight side. So I can't go more than a 1/4 inch. I don't want to go not very deep, otherwise you start cutting with the tip and the finish does not look very good. So I'm going to go -2. All right, that's fine, and we need a 20 thou chamfer. So I'm going to put -20 thou in here. Now notice this says stock plus or minus. Anytime you leave positive stock, it leaves material. Doesn't matter whether you're cutting ID or OD, it leaves material, but I want to force it into the material by 20 thou, so I'm going to put 20 thou. Make sure you uncheck ramp, otherwise it's going to ramp down, and you'll click on do it, and there this one is. Make sure you choose, of course, this side you want to cut on, and if you want to climb mill or conventional, that's up to you. Most of 99% of the time you want to climb mill on a CNC. Okay, the next operation, we're going to do the left pocket. Same scenario here. Let me uncheck ramp down, and you'll click on do it, and there's that one. And the last one is the chamfer on the outside. Again, -20 thou, and I should probably put, we're going to go -150 there, because we have kind of sharp corners there, and if you go too deep, then it leaves a larger chamfer on there, which is undesirable. So I'll just click on redo, and there you have your part finished. Let's run through the whole thing. I'm going to uncheck this box. This will just let it run through everything. And one thing we want to do here is I always turn on colors here. As you can see, you can do it by tool number. If you do Gibbs colors, it's going to leave everything blank, and you're not going to know what tool is cutting what. But this is just going to show it all as gray. If that's how you like it, that's fine. But I like to show colors, so you can do it by op number or tool number. Normally it's tool number. And if you don't like these colors, you can just double click and change it to whatever color you would like. So let's rewind and play. And there's my facing. There's my roughing. We'll speed that up a little bit. And the pockets. And we'll slow it down a little bit there. Okay, now we're going to slow it down and do the spot drills. And now the 187 drills. 3/8 drill. Now we're going to chamfer. Chamfer the outside. And looks really good. Now the only thing that we may want to add might be the vise to hold on to this. So let's finish off using a vise. So I'm going to turn off cam. Anytime I bring in geometry or solids or anything like that, I always turn the cam off so I don't accidentally delete something over here. So I'm going to bring in my solid model by going to File and Import. And I'm going to click on the Curt D675 Vise Simplified. It's going to bring in my vise. And when I created this vise, and you can download this from Kurt or any of the other manufacturers, I put the origin on my vise over the top left corner, because anytime you bring in a solid model in with Gibbs, it matches where the origin is on your solid model to the origin on your part, and that's why it looks like it's right there on the corner, because it is. I'm going to go to top view. You can see it's not quite centered, and that's intentional because this is where the coordinate system is on my part and my vise. I want to move this kind of to the left, but first we want to make this vise a fixture. If I click in space, it unselects the vise, and you can see this comes in the color I chose when I set up my screen. But we want to make this a fixture, so I'm going to make sure face selection is off, hold the control key down, select the vise and the rear jaws. While I'm there, right click, go to show properties of selected. It's going to show everything I selected there, and I'm going to change it to fixture display only and put chord height 10 thou. Now the reason it's fixture display only is I want to have Gibbs render it as a fixture. That's why it says display only, but it's not going to care if I cut into the part. It's not going to give me a warning or anything, and it'll allow me to create a toolpath, because sometimes you want to create a toolpath to make soft jaws, so you want to cut into the vise. But if you click on fixture, when you do a toolpath, the tools are going to avoid the vise and stay away from it. But I'm just going to do fixture display only, click apply to all, click in space, and the default color is red unless you change the color. So I need to move things around just a little bit. Click the vise in here, and I'm going to go to modify and translate. I'm going to move the X over probably ½ inch. Let's see if that'll look good there. Yeah, that looks pretty good. You can always extract the geometry off the vise if you want to get it perfectly and exactly how you want it. Now, as you can see, if I render this, let's just render that and you'll see what's going to happen. Let's speed it up. As you can see, of course, it's cutting into our part. Doesn't look too good. So I need to make sure I move my vise down. I'm just going to go to a sideways view here. Again, I'm going to click on the vise, go to modify, translate. Don't want to move it any more in X or Y. We know our part's 1 inch thick and our material's 1 1/4, so I'm going to go minus 1.0, we'll say 0.50. And that moves our part down. I'm still holding onto our part. Now I'm just going to adjust the rear jaw. I'm just going to guess on this. Maybe a little bit more. Okay, that's pretty close. Like I say, if you want to get exact, you could extract the geometry off there and put it right on the money. Now, if I render, you can see everything looks pretty good there. So that is how you machine your very first part in Gibbs. Of course, you can change the rendering, how you want to see it, by right-clicking up here, going to settings, and say I want it just fast. Click apply, and when you render, it'll even go full speed. It'll even go faster. But it looks a little chunky, as you can see there. Okay, it's just made to go fast. If you click on that setting, you can click accurate or custom. The posted code is going to be the exact either way you choose, but if you want to see more of a smoother part, you can click apply. You can always have it beep or stock if it encounters a crash, and you can see this looks pretty good there. So that's your first mill part. Hope you learned something here. Thanks again for watching.